Check, check. Happy New Year, everyone. Hope you had a good Christmas and New Year's. And I hope you're ready to dominate 2023. Now, I'm not sure how many people are joining in the live stream today, but if you're watching this after the fact, then we'll be going through plenty of exam questions. So this is going to be a great revision video for you. As well as a live stream if anyone does join in the live stream today. So we're going to get pretty much stuck straight in to the questions. It's like an exam paper here, so there's about 22 questions in this paper, I think. And yeah, we'll see how we go. If you are at any point well, I guess if you're not here, then you're not here, so there's no point saying it. But if there's anybody there in the live chat, please say hello. Please join in. Stick any questions you have in the chat. And if you're watching this after the fact, be aware that the live streams are going on weekly, usually. That's what we're trying to stick to. Now, I do have a co-host, as you would say. Sometimes, Mr. T Formula sometimes joins me. He's not joining me today, but maybe he'll jump in at some point, hopefully, to have a chat. Hello, I'm not American. Take another guess. Actually, I went back home, as you might say, over Christmas to see my family. Yeah, 10 points to you if you guess correctly where I was born and where I grew up. Alrighty, so let me just check you can see. Yeah, hopefully you should be able to see what I'm looking at now. So we've got we're going to start off, as most exam papers do, they start off with the easier questions and then they get progressively more difficult. Okay, so, well, depending on what level you're at, these first few questions might be the questions you want to be sticking to revising on. So we have an inequality here. It says solve 4y plus 5 greater than 12. So what is y? Well, y could be anything, except it can't quite be anything, can it? Because 4y plus 5 must be greater than 12. So there's a restriction on what y can be. Will the live stream be uploaded? Yes, it will be uploaded. So this will be a VOD after the fact. So, you know, if you want to use this for revision purposes, then you can just, you know, pause and go through the questions in your own time, if that's what you prefer. But the live stream is also useful. Some people prefer to join in the live stream and, you know, stick questions in the chat and interact. So that's why I'm live streaming occasionally as well. Okay, so 4y plus 5 must be greater than 12. The way we generally approach these inequalities is we treat them kind of like an equation. So when we have the equal sign, you know, you can think of it as a balancing scale. You can take things from the left-hand side and move them to the right, and you can do some manipulation in that way. So this plus 5, I want to remove it from the left-hand side. If I do that on a balancing scale, if you take 5 things from the left-hand side, you need to take them also from the right-hand side. So what I'm going to do here is take 5 from both sides. So I'm going to have 4y greater than 12 take 5, right? And I have a video on this process on solving equations if you want to you know, revise that in more detail. So now I have 4y greater than 12 take 5. That's 4y greater than 7. Okay, so now if I have 4 multiplied by y, I just want y by itself, so I divide that 4y by 4. So divide both sides by 4, and then I get y greater than 7 on 4. And if you're in an exam situation, it can be a little bit scary when you end up with a question like an answer like this, like a fraction, a mixed fraction. But just double check your working and be confident that, yeah, even though the answer looks a bit messy, you've done everything correctly. So y greater than 7 on 4 is the correct answer there. Okay, next one. Solve 6x take 5 equal to 4x take 7 on 2. Okay, well, there's a few more steps involved here. The first thing I want to do is get rid of the fraction. Okay, so I'm going to rewrite the whole thing down below. I like to do this sometimes when there's a few steps involved. I just rewrite the equation in my own way. So this helps to just get a feel for actually what you need to do. So if I'm dividing by 2 on the right hand side, the opposite operation of division is multiplication. So if I want to remove that divided by 2 from the right hand side, I can multiply both sides by 2, and this will just be 4x take 7. I'll get rid of that divided by 2 if you like. So dividing both sides by 2, I'll have 2 times the left hand side, 6x take 5, equal to 4x take 7. Okay, so think of that balancing scale. If you want to get rid of something from one side, you've got to do that thing to both sides. So multiply by 2 on both sides. Then I've got 12x take 5 equal to 4x take 7. So I've expanded those brackets and I've made a mistake already. Hopefully you spotted that. 2 times negative 5 is negative 10. Then I want all of the x's on the same side. So I want this 4x on the left-hand side. If I've got a positive 4x, I want to subtract 4x from the right-hand side, also subtract 4x from the left-hand side. So 12x take 4x. Going to do a couple of steps in one go there. 12x take 4x is 8x. Then this negative 10, I want to add 10 to the left-hand side and also add 10 to the right-hand side. So that's going to be negative 7 plus 10 is 3. So I did a couple of steps in one go there. Hopefully you've followed. Just rewrite those again. So I subtracted 4x and added 10 to both sides. Okay, next, well, I have 8x equal to 3. This is similar to what we had up here. We had this 4y greater than 7. Remember, we divided by 4 there. So here we're again going to divide, and here we're dividing by 8. So divide by 8, we get 8 equal to 3 on 8. So final answer there is 3 on 8. And that was a 3-mark question, and the total marks for question 1 is 5, so the first part was 2 marks. I'm not sure why it wasn't written up there. Okay, hopefully that's all good. On to the next one. Write down the value of x to the power of 0. Hopefully you know what anything to the power of 0 is. That's always 1. This is how we define it. It's interesting to think about what does it mean for something to be raised to the power of 0. And there's a few interesting videos on YouTube talking about that. But yeah, we generally just say we define it as 1. Okie doke. Given that 2 to the power of negative 3, this is written a bit funny, but this is just like a formatting error. This is meant to say 2 to the power of negative 3 times 2 to the power of 9 equals 2 to the power of n. Find the value of n. Here you need to remember your index laws. What do we do with the powers when we're multiplying numbers with the same base? We add those powers. So here, because we have all of the same base numbers, we can say, well, negative 3 plus 9 must equal n. So we create our own equation here. Negative 3 plus 9 is 6, so n must be 6. Alrighty. If anyone has any questions at any point, please jump in. Next one. Given that 7 to the power of 206 times 7 to the power of n over 7 to the power of 214 equals 7 to the negative 3, find the value of m. Again, think of your index laws. Don't be scared of these large numbers. When we're multiplying the numbers with the same base, we add the index numbers. So in the top line of this fraction, we're going to have 206 plus m and as the index numbers, and then when we divide by 7 to the power of 214, we subtract that power, and then this must be equal to the power of 7 on the right hand side. So again, we create another equation, and here we can solve for m. So 206 take 214, that is, what's the difference there? 8. So that's negative 8. So this could be written as m take 8 equal to negative 3, and then plus 8 to both sides. Again, we're solving equations. Plus 8 to both sides, m is going to be 5. Alright. All good so far. Hopefully I'm explaining those okay. Question 3 is on standard form. It says, write 5 times 10 to the 4 as an ordinary number. This is written in standard form. So what are we multiplying here? We're basically multiplying by 10,000. 10 to the power of 4 is 10,000. 10,000. That 4, well, a shortcut is to say, well, when we raise 10 to the power of anything, we add that number of zeros. So, or we need that number of zeros after the 1. So 10 to the power of 4 will have 4 zeros after it. So 5 times 10,000 is 50,000. Write 0.00006 in standard form. One way to do this is to move the decimal place in front of the 6 and count how many times you move it. So that's 1, 2, 3, 4, 5. I moved the decimal place 5 times. And so then, because I'm moving it forward, it's going to be multiplied by 0.00001, and that's 10 to the negative 5. So that's interesting actually. So we've got 4 zeros before the 1, or should it be 5 zeros? 5 zeros before the 1. So, well, the answer is 10 to the negative 6 times 10 to the negative 5. So, yeah, you're multiplying 6 by, no? Yeah, you're multiplying 6 by 10,000th. I was looking for a neat way to connect the negative 5 to the zeros. But, yeah, anyway. I hope you haven't confused you there. Basically, you just think about how many times you're moving the decimal place to the right, and this first number needs to be between 1 and 9. So the decimal point needs to be in front of the 6 there, and because we moved the decimal point 5 times, we get 6 times 10 to the negative 5. Okie doke. Question 4. Complete the table of values for y equal to 6 on x. Alright, so basically we're plugging in the x values into this equation here and getting the values of y. 6 divided by a half, double 6 is 12. 6 divided by 2 is 3. 6 divided by 4 is 6 on 4, or 1.5. Okay, so 6 on 4 is also 3 on 2. Hopefully you know that fraction is 1.5. And then 6 on 5 is 1 and 1/5. 1/5 is, well, think about 100 divided by 20. 20 on 100 is like is the same as a fifth. So, well, I was thinking about a way to describe this as 1.2. Well, this is 2 on 10. Yeah, so 0.2 is 2/10. Okay, so 1 and 1/5 is the same as 1.2. Okie doke. And then we need to graph it. Hopefully I can do this neatly. X equal to 0.5 will be somewhere around here, somewhere around there. 1, we have another point at 1,6. Whoops, let me do that again. 1,6. Then another point at 2,3. Then another point at 3,2. Then 4, 1.5 would be about there. Then 5, 1.2. Oops. 5, 1.2 would be here. And then 6, 1. Okay, so we have like kind of, well, yeah, it's a hyperbolic graph, isn't it? Okay. Hey, that's not too bad for a first try. Okay, but make sure you sketch that more neatly in your exam. pen on paper should be a bit easier than this program I'm using. Alright. Next one, bit of a formatting error here. It says complete the table values for y equal to x squared take 4x plus 3. And here we have our table. So let's do some rough notes. So we're plugging in -2 into this equation. So we're going to get -2 squared take 4 times -2 plus 3. So I've plugged in -2 for x in this quadratic here. So this is going to give us 4 plus 8 plus 3. That's 12 plus 3. That's 15. Right. I think I've done that correctly. Then we're plugging in 1 for x. So we're going to get 1 squared take 4 plus 3. That's a bit easier. 1 take 4 is -3 plus 3 is 0. Then we're plugging in 2. So let's rub out our notes. One thing I don't like about these types of questions is they don't give you any room for any working out. They just kind of expect you to have some rough note paper. But anyway, next one. Plugging in 2 for x. This is 4 take 8. 4 times 2 is 8 plus 3. 4 take 8 is -4 plus 3 is -1. And then plugging in 4, we get 4 squared take 4 times 4 plus 3. That's 16 take 16 plus 3 is 3. Okie doke. Not too bad. Then we have to graph this one as well. Alright, so let's plot our points. Just a second. Okay, so we have a point at -215. -215 is up here. -18 is here. 0,3 is here. 10 is down here. 2, -1, and 3, 0, and one more at 4, 3. Okay, alright, again, we're trying to sketch this as neatly as possible. Oh dear, this one's not going as well as the last one. Okay. Okay, oh, not too bad. And it looks like a quadratic, kind of. Okay. Alright, so some graph sketching there. Filling in tables of values and graph sketching. Now we're on to some more index laws. Let me zoom in a bit more again. There we go. Okay, question 6a. Simplify x to the power of 4 times x to the power of 5. We've talked about this already. What do we do when we multiply numbers with the same base? So x can be anything, but it's the same. So we've got the same number multiplied by these powers, and we're multiplying them. So we can add the index numbers. So 4 plus 5, we get x to the power of 9. B, when we have something raised to the power of an exponent, we distribute that power to both terms in the brackets, or both numbers in the brackets. So you can think about this as 4 to the power of 3 times y squared to the power of 3. You could write it as like this as well. And then we need to work out 4 to the power of 3. This is a non-calculator paper, so you need to be able to do that without a calculator, obviously. So 4 times 4 is 16. Well, yeah, 4 to the power of 3 is 4 times 4 times 4. 4 times 4 is 16, times 4 is 64. So that's that part sorted out. Then here we've got y squared to the power of 3. We multiply those index numbers when we have brackets. So it's 2 multiplied by 3. So that gives us y to the power of 6. Alright, that's some index laws. Then we have a quadratic we need to factorize. Hopefully you have a method to do this. I'm not going to really describe a method here. I'll just sort of do it the way that I encourage you to do once you've kind of mastered this topic. I have a video on factorizing quadratics where I talk about different methods you can use. And once you're confident, you should kind of be able to look at this number, this constant on the end, 12, and think of factors of 12 that sum to the coefficient of n. So factors of 12 are 1 and 12, 2 and 6, or 3 and 4. I'm going to go with 3 and 4 because I know that 3 and 4 sum to 7. And then I'm going to write my double brackets. Because it's a negative 7, I know it's going to be negative 3 and negative 4. Okay, so again, if you want a method to do that, check out my video on factorizing quadratics. But yeah, once you get really good at this, it becomes quite fast. You can look at that number and think of factors in your head and kind of do this quite quickly. Okay, so that was question 6. Index laws and factorizing. Question 7 gives us this expression. It says expand and simplify n times n take 4 times 3n plus 5. Alright, so I would suggest expanding the double brackets first. So I'm going to leave that n out the front, and then I'm going to expand these double brackets using FOIL. I have a video on expanding double brackets if you want to check that out. FOIL means first, so the first terms, n times 3n, is 3n squared. Outers is the outer terms, 5 times n, plus 5n. I is the inner terms, negative 4 and 3n. Multiplying those, that's negative 12n. L is the last terms, negative 4 and 5 is negative 20. Okay, then simplify or combine like terms. So this is 3n squared plus 5n take 12n is negative 7n. And then multiply everything by n. That gives us 3n cubed take 7n squared take 20n. And hopefully I haven't made any errors there. Okay, okie doke. Alright. That was 2 marks. Question 8 says, write down all the values of n such that n is greater than or equal to negative 2 and less than 3. So here it says n is an integer. That's important information. So if it's greater than or equal to negative 2, n could be negative 2, or negative 1, or 0. 0 is also an integer, or 1, or 2. It can't be 3 because it's strictly less than 3. Part B says, on the number line represent the inequality y less than or equal to 1. Okay, here I think the key piece of information is whether to do a filled-in circle or an empty circle at 1. So because it's less than or equal to, we do a filled-in circle, and then we have a line pointing down the number line all the way to infinity for any values less than 1. So the filled in circle means that's less than or equal to. If it was just less than, it would be an empty circle. And the same thing. But we don't have that, so there you go. Alright, some inequalities. Question 9 says write down an equation of the straight line with gradient -3 which passes through the point with coordinates 0, 5. Straight line. As soon as you see straight line, I hope you're thinking y equals mx plus c. Y equals mx plus c, where m, what is m? That's the gradient. And what is c? That's the y-intercept. Okie doke. So now, well, they tell us the gradient is -3, so we can plug that straight in for m. And also, if they tell you it passes through 0, 5, 0, 5 is the y-intercept because 0 is the x-coordinate. If x is 0, that means the point will be on the y-axis. So here we have enough information to straight away say this straight line will be y equals -3x plus 5. Okay, so again, if we have that point 0, 5, that will be on the y-axis, so that's immediately telling you the y-intercept is 5. Okie doke, so that's question 9, finding an equation of a straight line. Given that information, on to some problem solving, something a little bit more in depth here. This question says the diagram shows a shape made from 6 identical squares. The total area of the shape is 5,406 centimeters squared. Find an estimate for the length of one side of each square. Give your answer correct to the nearest whole number. Okay, estimate. That's kind of nice because this number is not so nice. So, well, what could we do first? Well, first we notice that there are 6 squares and they're identical. So we can divide this total area by 6 to get the area of one square. So the operation we're doing is 5,406 divided by 6 for the area of one square. And because we're estimating, well, let's round this 5,406 off to 5,400 to the nearest 100. That's a pretty reasonable estimate given that we have a number in the thousands. So this is going to be approximately 5,400 divided by 6. And 54 divided by 6 is nice because that's in your 9 times tables. That's going to be 900, right? 9 times 6 is 54. So 5,400 divided by 6 is 900. So this was the approximate area of one square, right? So, but let's remember what the question is asking. It says find an estimate for the length of one side of each square. So if the area is 900, what does that mean the side length will be? Well, if it was 9, it would be 3. So if it's 900, it would be 30. 30 times 30 is 900. So we have an estimate here for the side of one square of 30. Okay, nice question there. A couple of steps needed and also a bit of estimating as well. It's worth thinking a little bit about Hi Nescafe. We'll get into some harder questions towards the end of the paper. Hopefully they're a bit more challenging or more challenging for you. But it's worth just pausing for a minute on talking about what other estimates you could have made. So some people might have done, rounded it off to the nearest 5. No, that wouldn't be easy because you're divided by 6. Yeah, I think 5,400 is well, I can't really think of another reasonable estimate you could use there. Yeah, 6,000 is just way off. You can't really go to 6,000. We'll get there. We'll get there. There's some vectors questions, or there's a vector question at the end of this paper that's quite good. Hopefully you like it. Okay. Alright, question 11. Show by shading on the grid the region defined by all three of the inequalities. Okay. So, what does this mean when x is less than or equal to 6? Well, here is 6 on the x-axis. X less than 6 is anything, in this area. So we can draw a line at 6 on the x-axis, and that area below 6 represents x less than or equal to 6. If it was x less than 6, you need to do a dotted line. Because it's less than or equal to, we do a solid line. And all of these are equal to as well, so we don't need to do any dotted lines here. Y greater than or equal to 2. Here's 2 on the y-axis. So we draw a horizontal line at y equals to 2. There we go. And so the area above that line represents y greater than or equal to 2. Then we have the straight line. So when you're plotting this line, think about it as y equal to x plus 1. So plot this straight line. That's a straight line starting at 1 on the y-axis, and it has a gradient of 1. So it's going across 1, up 1 each time. Okay, so there we go. That would be the line y equals x plus 1. And the region, when it says y less than or equal to x plus 1, that's everything below that line. You learnt what 1 month ago? I'm curious. Pythagoras' theorem. What sort of questions on Pythagoras' theorem? I can talk about it after I want to go through this paper first, and then I can go through some other questions, and I can take some of your questions, and I can talk about Pythagoras' theorem then. But I'll finish this paper off. I'm halfway through now, so I'll finish this question off first. So when we have x less than or equal to 6, that's below this line. So we can shade along this edge of that line. Y greater than or equal to 2, that's above this line. And y less than or equal to x plus 1, that's below this line. So our shaded region is going to be in here. And it says label the region R, so that's that region in there. Okie doke. So that is shading inequalities. That's an important topic to revise. Often these questions come up in exams. And also, well, yeah, we'll stick with that. Okay, question 12. Make t the subject of n squared equal to 4d plus t cubed over t cubed. So, well, one way to do this is to get rid of this fraction first. So how do we get rid of something when we're dividing by it? We can multiply by t cubed on both sides. So we're going to have n squared multiplied by t cubed equal to 4d plus t cubed. So there I've multiplied by t cubed on both sides. So I've got rid of that denominator. Do the opposite exactly. Thank you, Nescafe. Now I want all of the t's on the same side. So I have the t cubed over here and a t cubed over here. And I'm adding this t cubed, so I want to subtract that. Yeah, do the reverse order of BODMAS. Yeah, that's a good approach. Sometimes. Sometimes it doesn't exactly work to do the reverse of BODMAS. I'll try to think of an example in a minute, but here we have the plus t cubed, so we can subtract the t cubed. So we have n squared t cubed take t cubed equal to 4d. Now we have t cubed, all the t's on the same side, so we can factorize a t cubed out of these two terms. So if I factorize t cubed out of n squared t cubed, I'm left with n squared. And if I factorize t cubed out of t cubed, I'm left with 1. Okay, and now all we need to do to isolate t is divide by this term here, dividing by n squared take 1. That gives us t cubed equal to 4d over n squared take 1. Alright, and the last step, how do we get rid of a cube? We take the cube root of both sides. So t is equal to the cube root of 4d over n squared take 1. Okay, and that's your final answer. That was 4 marks for that one. So these questions, I guess, can often be quite difficult and challenging. And I remember when we looked at the examiner's reports, these make something the subject of were often where students lost some marks. So this is a topic worth practicing. And if there's anything in there, you know, any steps, maybe the first step or somewhere in the middle that didn't quite make sense, ask a question, or if you watch this after the fact, leave a comment asking to clarify, and I can make a video on this topic as well. But yeah, when do we not always use reverse BIDMAS? So sometimes, let me try to think of an example. Sometimes we might have yeah, it's hard to think of an example off the top of my head. But sometimes when you're solving equations, it can be helpful to, you know, do an addition or a subtraction before you do a multiplication. But yeah, generally that's a pretty good rule. Yeah, I can't think of an example right now. Apologies for that. Okay, final answer there, cube root of 4d over n squared take 1. Alright. What is kind of easy? I'm not sure. You meant trigonometry or Pythagoras' theorem? Is that what you meant? Okay. Question 13. A group of 60 students. Okay, so this is cumulative frequency. Yeah, this can be, well, yeah, I've had classes that have said they really dislike this topic. I've had other classes that said this is fine, have no problem with this topic. So this can be a bit of a mixed bag. But this question says a group of 60 students each sat an algebra test and a geometry test. Each test was marked out of 110. The cumulative frequency graph gives information about the marks gained by 60 students in the algebra test. Okay, so here we have the graph. It says use a graph to find an estimate for the median mark in the algebra test. Okay, so this is, so a common place to trip up here is to take, you know, start on the x-axis, find the middle of the x-axis and go up to the graph. But here, you want to, the median is the middle student, not the middle mark, the middle student. So we have 60 students, so we want to start on the y-axis and go across the graph. So the middle student will be the 30th student. So we go from 30 across to the graph, and then down for the median. So for the median, start on the y-axis. That gives us a median mark of, if we look at this scale here, it's going up in 2s. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So this would be 48, this one here. So that gives us a median of 48. Oh, thank you. Well, I hope I can explain things such that you know, it's not enough to be smart. It's more about being able to help others if you're trying to teach. Always use BODMAS. Okay. Yeah, I think if that's the way you've learned it, then go with that. Don't let me confuse you. So if that's the method you've learnt, I'm sure it's fine. I'm not trying to say it's wrong. I'm just saying sometimes it can be a bit slower, but it will always work as well. So yeah, use the method that you're confident with. Okay, so part B says use a graph to find an estimate for the number of students who gained 58 marks or less in the algebra test. Okay, so here, because we're talking about marks, we look at the x-axis. We start on the x-axis, here's 58, and then we go up to the graph. Okay, so this is where we start on the x-axis, go up to the graph, and then across. And we get here, the scale on the y-axis is 1, so each line is 1, so this is going to be 46. So the question was the number of students who gained 58 marks or less. 58 marks or less would be 46. 46 students gained 58 marks or less, yeah. Part C says use a graph to find an estimate for the interquartile range gained in the algebra test. What is the interquartile range? That's between 25% and 75%. So what's a quarter of 60? Divide 60 by 4. That's 15. So we start at 15 on the y-axis. We go across to the graph and down. Oops. Across to the graph. Try that again. It's not cooperating now. Okay, but that's going to be at 40. Okay, then 3/4 of 60. Well, if we divide it by 4 and it's 15, multiply that by 3. 15 times 3 is 45. So we go up to 45. This one worked a bit better. 45. Nope. 45. Across to the graph and down, and that's the 75th percentile. That's going to be 56. 56 here. Okay, so the 25th percentile was 40, the 75th percentile was 56. That gives us an interquartile range. That's the difference between those numbers. 56 from 40 to 56 is 16. So we get 56 take 40 is 16. So 16 for an interquartile range. Yep, and then part D says the interquartile range of the marks gained in the geometry test is 9. Lewis says the students' marks are more spread out in the algebra test than in the geometry test. Is Lewis correct? Give a reason for your answer. What do you guys think? Is Lewis correct? I'll just take a moment to have a drink. Anyone? Anyone? the interquartile range is a measure of spread. Okay, so if we have a higher interquartile range, that means the marks will be more spread out. So we can say yes, the interquartile range for the algebra test is greater than the geometry test. No problem. I'm not trying to make you feel dumb. I'm just trying to make you think. Like, it doesn't matter. If you're wrong or right, it's whatever, you know? Hopefully it just means you learned something, that's all. Okay, luckily I didn't see that message. Alright, so the next one says, to be awarded a grade A in the algebra test, the student had to gain a mark greater than 64. 2 students had to be selected at random from the 60 students in the group. Use the graph to find an estimate for the probability that both of these students were awarded a grade A in the algebra test. Okay, quite a lot going on in this question. Hello, Joseph. Welcome. So a student had to gain a mark greater than 64. So let's firstly work out how many students gained a mark greater than 64. So we go to our graph and we go to the marks and we find 64, which is here. We go up to the graph and then we get 50. Okay. So that means 10 students gained a mark greater than 64, right? Or in other words, 50 students gained less than 64 marks. Okay, so we get 10. So I'm going to write that down. 10 students gained more than 64 marks. Okay. So that means the probability of selecting a student that got an A would be 10 out of 60. So the probability of selecting a student that got an A equals 10 out of 60, or 1 out of 6. Alright, can you simplify that one? MO? Okay, so, but we need to select 2 students. So the first one's going to be 1 out of 6. So the probability here, I'm not going to write out the whole thing again. Probability here for the first student is going to be 1 out of 6, or 10 out of 60. But the second student, well, if we've already selected a student, then we're going to have 9 we're going to have 9 students left in that A grade bracket, and we're going to have 59 total students left to select from. So this is going to give us our probability if we do this operation. Right, so we selected a student, we got one of those 10 that got a grade A, then we have 9 students left that got a grade A, and we have 59 students left in total to select from. And we multiply those because well, we need to think about probability laws when we're doing conditional probability. and we're selecting from a group without replacement, we do we think of that as 1, 6, and 9 out of 59, and we multiply those. Another way to think about it is to think of it as a tree diagram. And a tree diagram is multiplicative in that way. So, one branch multiplied by 3 is, or 2 multiplied by 3. If you have 2 branches and 3 branches coming off those 2 branches, that's 2 times 3. Okay, I made a bit of a mess of that explanation, but anyways, here we can cancel the 3's. 9 divided by 3 is 3, 6 divided by 3 is 2. So for a final answer, we're getting 3 over 2 times 59, or 3 over 118. Which, I'm not sure if 90 over 3,540 simplifies to that. Could put that into a calculator quickly. Let's see. Let's see. 90 over 3,540. Yes. Correct. Well done. Okay. All right. So that was question 13. Quite a long question there on cumulative frequency. Total of 8 marks. Okay, on to question 14. It says express 3 over x plus 2 over 2x plus a quarter as a single fraction in its simplest form. Okay, here we want a common denominator. The common denominator of x and 2x and 4, or in other words, the lowest common factor of those 3 terms is going to be 4x. So the first term we can multiply by 4. So let me write the whole thing out again. Oops, again, I like to do this occasionally when I have a problem that's going to require a number of steps. I'll just write the problem out again. And as I said, the lowest common denominator is going to be 4x. Because that is the term that all of these denominators are factors of. Okay, so to give 3 over x a denominator of 4x, I need to multiply that by 4, so that's going to be 12 on 4x. Here I need to multiply the second fraction by 2, so that's going to be 2 times x plus 2 over 4x. And then the last one multiplied by x, that's going to be x on 4x. Alright, now we have the same denominator. We can combine these fractions. So this is going to be 12 plus 2x plus 4 plus x all over 4x. Oops. And then combining like terms, this is going to be 16 plus 3x on 4x. And I think that's the best we can do. So we leave it as is. Alrighty. Next question is on circle theorems. Which ones didn't you understand? Do you have a question on the last one? combining algebraic fractions. I think the key step here is to realize how to find the common denominator. And that goes back to finding common factors of terms or finding multiples of terms. So yeah, another, like, if you remove some of the complexity from this question, I could ask you, what is the lowest common factor of these three terms? Find the lowest common factor. Lowest common multiple of these three terms. So that would be a step you could practice. Okay, what if I said find the lowest common multiple of these three terms, x, 3x, and 5. What would be the common denominator there? Okay, well, if you're in year 9, we're doing year 11 GCSE stuff, so it's not too bad that you're not confident with this stuff, really. Algebraic fractions you're probably not going to do yet. They are probably coming up this year, maybe. But you could give this a go, finding the lowest common multiple of x, 3x, and 5. Well, firstly, you look at the numbers, 3 and 5. What's a common multiple of 3 and 5? Well, that would be 15. And then because we have the x, you need to include the x. So the lowest common multiple of these three terms would be 15x. So if these were the denominators, you would have a common denominator of 15x. But yeah, that was just an example of questions you could practice. Okay, moving on to circle theorems. This question says A, B, C, and D are points on a circle, center 0. AOC is the diameter of the circle, angle BAC equals 55 degrees. Work out the size of angle ADB. Give a reason for each stage of your working. Alright, circle theorems. Who likes circle theorems? Work out the size of angle ADB. That's this one here. Okay, how are we going to find this angle? Wow, someone's really quick in the chat. Couple ways to do this. Okay, if you already think you have the solution, can you find two methods to get to the solution? There are at least two ways to do this, probably more. But one way is to recognize that these two angles, ACB and ADB, are equal. Okay, because they're angles subtended by the same chord or the same arc. Yep, that's one method. Okay, so because these two angles are equal, if we can find this angle, we'll be able to find this angle down here. How can we find this angle up here? Well, if we look at this triangle, that's a big line. That is a big line. Don't want it to be that big. If we look at this triangle, if we can find all the angles in this triangle, we'll be able to find that angle ACB. Alright, well, we actually know that this angle up here must be 90 degrees. Okay, why? Because it's an angle in a semicircle. Check out my video on circle theorems. If you're not sure about this, I go through a proof of this fact. Because AC is a diameter, that tells us that BC must be 90 degrees. It's the angle in this semicircle here. So that's the first thing I'm going to start off with. I'm going to say angle ABC equals 90 degrees because it's an angle in a semicircle. Then, because this is 90, I can find ACB because angles in a triangle add up to 180. So angle ACB equals 180, take 55, take 90, because angles in a triangle equal 180 degrees. Okay, and the reason I'm writing the right reasoning is because it says give a reason for each stage of your working. 180 take 90 is 90, take 55 is 35. Okay, that was ACB in here. And remember we said this was equal to ADB. So then all we have to say is angle ADB equals 35 degrees due to the angles subtended by the same arc or same segment or same chord. Subtended by the same arc. Theorem. Okay, so final answer there is 35 degrees. How often do we do these? Weekly. That's what we try to stick to. Yeah, we'll see how we go through the year. But I'll say weekly. So next Tuesday should be the next one. Alright, the other method. Did you find the other method? Or at least one other method, there's probably more. You could draw an isosceles triangle in here, because that's a radius, so this must be an isosceles triangle. This angle is 55. That means this angle is 70. And then this angle here is twice the angle at the center, so it's half the angle at the center, so it's 35. So that was the other method. Okay, final answer there, 35 degrees. Just a reminder, this video will be uploaded as a video after the fact, so if any of these questions I go through too quickly or you want to spend more time on, you can watch the video afterwards and pause the video and try the question yourself. Okay, or you can also pause the live stream on YouTube. That's a nice feature of YouTube. You can actually pause the live stream. If there's any question you want to have a go at and you don't want me going through explanation while you're trying it, you can just pause the live stream and then catch up later on. Okay, so question 16 says, given that A, B, and C are integers, express 3x squared plus 12x plus 19 in the form A, x plus b all squared plus c. So this is this means we're completing the square. Completing the square. Okie doke. Alright, okay, so when we're doing this, if we have a coefficient of the x squared term, I recommend just factorizing or factoring it out. So I'd factor by the 3 out, so then we get 3 times x squared plus 4x. And here we get a bit of a messy fraction, 19 on 3, but it generally makes the process easier. 19 on 3, 19 on 3 is, another way to write that is 6 1/3, so we could also, that might make it a bit more simple as well. T formula, hello. Okay, so you don't want to expand this expression. That's what we're trying to get to. So we want to work with this quadratic to get to something in this form. The way we do this, there's a process that's called completing the square. And here we look at this quadratic in here, and we take half the coefficient of x. This is the process. So once you do this, you'll see when you expand it out, you end up with this quadratic. So in brackets, we're going to write x plus 2 all squared. See, 2 is half of 4. And when you expand this expression out, you're going to have an additional plus 4. So we need to subtract 4. And then we have this 19 on 3. So we have, and I'm going to write that as 6 1/3. Okay? This is called completing the square. If you haven't seen this before, actually, I think T formula has a nice video on this topic. Happy New Year, Happy New Year. So feel free to post the link to that video in the chat if you want. Because I actually, well, I have a shorts video on completing the square, but it's not a full explanation. But yeah, this is the process. And then we simplify this. -4 plus 6 1/3 is going to be 2 1/3. Yes, wonderful videos on completing the square, all types. Awesome. So -4 plus 6 1/3 is plus 2 1/3. 2 1/3 we can write as a an improper fraction. That's going to be 7 on 3. And so if we write it in that way, when we expand the 3 out, we are going to get 3 times x plus 2 all squared plus 7. And that's in the form they wanted it to be. A times x plus b all squared plus c. A is 3, b is 2, and c is 7. Alrighty. So I see we have a bit of a mix of age groups in the chat. So it's going to be a bit funny. Some of you are going to find this stuff a bit harder. Some of you are finding it a bit easier. But yeah. Well, hopefully it's good revision anyway. Alright, question 17 says the Venn diagram shows a universal set E and 3 sets A, B, and C. 6, 3, 8, 2, 5, and 4 represent the number of elements. So this is a bit of a different Venn diagram. The link's not working, right? Yeah, I thought that might be an issue. Well, check out, you can just click his channel and check his channel out anyway. So this is a bit of a different Venn diagram to what you might be used to, because we don't have the elements themselves, we have the number of elements represented. So A has 9 elements in total, and C has 7 elements in total. So this notation is also something that I haven't seen for a while. N, A, union B. That means the number of elements in A union B. So typically when you're doing Venn diagram questions, you just see usually A union B, and you'll need to give the elements themselves. Here we need to give the number of elements. So what does A union B mean? That means everything in A and in B. Everything in A and B. So can you count how many elements in A and B? That's basically what you need to do for this question. Okay, well, we've got 9 elements in A plus 10. It's going to be 19. The number of elements in A union C. 9 elements in A, 7 elements in C. I get 16 there. Now, let me just double check something. Question 17. Yes, the mark scheme gives 0 for this, and I'm not sure why. I hope it's a typo, but the union of A and C should be everything in A and C. If it was intersect, it would be 0. So I'm not sure if it's a typo or not, but okay. The number of elements in B intersect C complement. B intersects C complement. C complement is everything not in C. So that's everything in B but not C. So that's going to be 8 plus 3. So the 2 is in C, so we're not including the 2, which is in B, but it's also in C. So 3 plus 8 is 11. And then the last one, the number of elements in A complement union B complement union C complement. This is a bit of a funny question. So if you think about what this is asking, A complement is everything not in A. So that's 4, 8, 2, 5. That's everything not in A. But we also need to include everything not in B. So that's the 6 here. And we also need to include everything not in C. So that's that 3 there. So the number of elements not in A and not in B and not in C is actually everything in this universal set. So we need to add up all of these numbers. So 4 plus 6 plus 3, 13, 21, 23, 28. Okay, so for part 4 is 28. Going back to completing the square, how do we get the 7? How do we get the 7? Which step did not make sense? So I got negative 4 plus 6 1/3 is 2 1/3, which I changed to 7 on 3. 2 1/3 is the same as 7 on 3. Then when I multiplied everything by 3, remember I factorized that 3 out from everything. Excuse me. I factorized the 3 out from everything, so I need to multiply everything by 3. Not just this first set of brackets, but everything by 3. So 7 on 3 times 3 is 7. That's, yeah, something to, well, if that was the thing that tripped you up, then that's pretty, like I do that often as well. Maybe it was that, factorizing the 3, then multiplying by 3. Alright, hopefully that made sense. Okie doke. Part 18. This is on graph transformations. The curve with the equation y equals f of x has one turning point. The coordinates of this turning point are -6, -4. Write down the coordinates of the turning point on the curve with equation y equals f of x plus 5. I have a video on graph transformations, although I didn't go through these types of transformations of part 2, but I did go through this one for part 1. So when you have f of x plus 5, that means you're adding 5 to every point on that curve. In other words, you're shifting the graph up 5. F of x is a function, so it's any graph. So an example of a graph would be a quadratic, which maybe you've seen before. So you could, for example, graph this. It says it has a turning point at -4, -6. So we could say this is maybe somewhere down here. So this graph might look like this. It doesn't have to look like this. It doesn't say it's a quadratic, but it might look like this. So this could be an example of f of x. Again, this is not what it has to look like because it doesn't give us any information about f of x. But we don't need any information about f of x to say that this transformation will shift the graph up 5 units. So now, if we shift this graph up 5 units, it will be up here. So what happens to this turning point when we shift the entire graph up 5 units? What will happen to this y coordinate? Well, nothing is happening to the x coordinate. So the x coordinate stays the same at -6. Hello, Abishan. Nice of you to jump in and say hi. It's really nice when people come and say hello. Yes, I had a good Christmas and New Year's. I went back to Australia and saw my family. Thanks for asking. How was yours? So, adding 5 to that y coordinate, -4 plus 5, we're going to have 1. -6, 1 as the new turning point. Went to Germany. Nice. Good to hear, Abishan. Good to hear. Okay, next one. Y equals f of 3x. So this is a bit more of a tricky transformation. This one is a vertical shift. Vertical shift. When you have f of x plus something, f of x plus 5 or f of x take 4, that's a vertical shift up or down. F of 3x is a compression or a stretch. So this is a compression along the x-axis. And the rule we use here is we divide the x coordinates, so we're going from x, y to x on b. That's if b is greater than 1, but we'll just stick to this for now. So we divide the x coordinate by b, or this term inside the brackets. Actually, I'll just write 3 for simplicity's sake. So this is a horizontal compression. Horizontal compression. Alright, and weirdly, this is, as far as I was aware, this was not meant to be in GCSEs. Maybe someone will correct me, but this is for higher. I did do some, at the start of the stream, I did do some foundation questions that would be also applicable to foundation. So afterwards, you can rewind the stream and watch the questions at the start of the video. There's some good foundation revision questions there. Probably up to about question 9 or 10 would be foundation questions as well. Harder foundation questions. Okay, so for this coordinate, if we've got f of 3x, we need to divide the x coordinate by 3. So we get -2, -4. All right. Next part says a graph of y equals g of x is shown on the grid below. On the grid, sketch the graph of y equals 2gx for -1 to 7. Right, this is a vertical stretch. So for this one, we're going from xy to x to y. So for each y coordinate, we are now doubling it. That's what this transformation means. So this is a vertical stretch. All right, so if we look, for example, at the point 0, 2, the y coordinate now needs to be at 4. So we multiply that y coordinate by 2. When it's at 3, it needs to be at 6. When looking at the point 1, 1, now that y coordinate needs to be at 2. When it's at 0, it's going to be the same, right? 0 times 2 is still 0. -1 times 2 is -2. 0 times 2 is 0. 1 times 2 is 2. 2 times 2 is 4. So what I'm doing here is I'm looking at this point, looking at it as 2, 2, and I'm multiplying the y coordinate by 2. So 2 times 2 is 4. Then this point here is 3, 3. That becomes 3, 6. Right, so I'm multiplying the y coordinate by 2 each time. That's what this transformation means. Okay, so then we can draw our new graph in. There we go. And that would be y equal to 2gx. Yeah, this is a higher paper. G is not the gradient. G of x is another function. Sorry, I missed that question. G of x is another function. Just like f of x, but they've just given it a different letter. Okay, so this was the topic of graph transformations. If you weren't confident on this question, you can search graph transformations on YouTube. You can check out my video on graph transformations, where I go really in depth into this topic, explaining what all of this stuff means. So yeah, there's lots of resources if at any point you're getting confused. Next part of this question says a graph of y equals h of x. This is another function, h of x, intersects the x-axis at 2 points. The coordinates of the 2 points are -1, 0, and 6, 0. The graph of y equals h of x plus a passes through the point with coordinates 2, 0, where a is constant. Find the two possible values of a. Okay, this is a horizontal shift, this transformation here. Horizontal shift. And if it's plus a, then it's to the left, but a could also be a negative number. There's no reason why a has to be positive here. So this is a horizontal shift, a units, left or right. Well, let's say left. But if a is negative, it will be to the right. Okay, so let's draw a possible graph of this function here. So it passes through the points -1, 0. and 6, 0. So let's say this was a quadratic. It doesn't have to be a quadratic, but it might be. So it might look something like this. Oh, that's terrible. Okay, whatever. That's good enough. Okay, so it might look something like that. My name, Joseph. Thanks for asking. No one's ever asked what my name was before. You can call me Joe if you like. Can I do standard? Standard what? I'm not sure what you mean, sorry. Okay, so the graph might look something like this. And if it then passes through the point 2, 0, that means it's shifted either right or left. So let's say it's shifted to the right. How many units to the right has it shifted? From -1 to 2, that's 3 units to the right. That means A would be -3. If it shifts to the right, it's a negative. Again, I addressed this in my video on graph transformation. On graph transformations. And if it's to the left, then it's a positive. So if we shifted to the left, and the graph was over here somewhere, and it went through 2, 0, how many units has it shifted? From 6 to 2. That's 4 units to the left, so it would be +4. So there's 2 possible answers there, -3 or +4. Alright, so graph transformations, that was a total of 6 marks for that question. Okie dokie doke. I'll just have a quick break. I'll be back in a moment. I just need to go grab a drink. So, yeah, BRB. Okay. Alright, question 19. Find the value of m. Find the value of m. Okay, we're given that the cube root of 1 on x to the power of 4 equals x to the m. Find the value of m. Easier one, not higher. Alright, well, we can do different questions after this. I think I've got 3 more questions to go of this paper. Then we can do some different stuff after that. Alrighty. So what's the first step here? Well, this is kind of like the questions on index laws we were doing before, where we just need to equate the index number on the left to the index number on the right. So how can we write this differently is another way to ask this question. How can we write this term on the left differently? Well, the cube root, so if you have the cube root of something, another way to write that is x to the third. So this here we can write as 1 on x to the third all to the power of 4. That looks a bit funny, right? But then we can write it as 1 on x to the power of 4 on 3. And to write it as x to the power of something, if we have 1 over x, another way of writing that is x to the negative 1. So all of this we can write as x to the power of negative 4 on 3. So for m, we get negative 4 on 3 as our answer there. So index laws once again. There's, I think, been 3 questions or 4 questions in this paper requiring index laws. And in general, I think just in everyday life, understanding index laws can be useful. Yeah, just every now and again it pops up in weird situations where you just think, oh, I kind of wish I had a quick way of doing that, a quick way of kind of multiplying these things, or a quick way of working out those exponents. And well, a good example is standard form actually. So a lot of times in science we're writing large numbers in standard form, you know, like 6 times 10 to the 4. And then if you have 2 numbers in standard form and you're multiplying those, you know, index laws become quite useful there to simplify that quickly. Alrighty. Question 20, algebraic proof. Using algebra, prove that given any 3 consecutive whole numbers, the sum of the square of the smallest number and the square of the largest number is always 2 more than twice the square of the middle number. Hello, hello? Number is always 2 more than twice the square. Whoa, I'm getting some feedback there. Hello, hello?
Hi there, sorry, I need to turn your volume down.
Hey, thanks for joining in. How are you? How was your Christmas and New Year's?
That'll do it. Okay, so hello?
Can you hear me? Hello?
Okay. Sorry about this, 1 second.
T-Form is having some technical issues.
There we go.
Hello?
Okay, hello.
Hi, you can hear me now?
You know how it always does that thing where I have to change the speakers?
Oh, right, okay, yeah, cool. Yeah, I was just asking, how was your Christmas and New Year's?
Oh, it was very good. I don't know if anyone's a bit too young here, but I went to the Isle of Isla this time and spent about 2 weeks there. And it's basically a whiskey distillery island. It's no one living there, like maybe 2,000 people in total. 2 shops on the whole island. Just nice to get away.
Right. Whiskey holiday.
Kind of, yeah. We got more. I don't drink much alcohol,
Right.
so it's just to see the history of the place, really.
Sounds nice. Isle of Isla.
Yeah.
Sounds like one of those places where it's like you know, very isolated, and you can kind of just relax and
Oh yeah, it's lovely, and
get
everyone
some
says
peace and
hello,
quiet.
right? So that's very different to here or many places. You're driving around or you go past anyone, they give you a big smile, they wave, and I think that's really nice. It's community. And I feel when you don't have that, you sort of disappear a bit in the big cities, and it's harder to feel
Yes.
close to your neighbors and friends. And
You're going to love it. Well, Yeah, you would love it in Australia or New Zealand then. Everyone says, "G'day, mate. How you going?" Every single person
Yeah.
you walk past.
Yeah, there, I think I will. I'm taking a trip there, aren't I? Next summer.
Right.
Should be
Yeah.
good.
Yeah, I wasn't sure if you wanted to talk about it or not, but yeah.
No, that's cool. I'll just say for now I'm gonna take a trip to, what do you call it? Down under?
Nice. All right. So you ready for some maths?
Yes, sir.
Do you find, by the way, like I didn't do anything for maybe close to a month, and then I come back and I just like it's sometimes really hard to get my gears moving. Like just
Yeah.
to like yeah, just to attempt some questions. It can be feel like you're trying to push a tractor uphill or something, you know.
Yeah. I feel the same. It's sort of a deep I'm trying to cling on to the holiday in a sense, longer than I should, because it's actually probably what life is about rather than duty. It's starting work again after a break can be quite challenging and intimidating.
Hmm.
Um, but I think sometimes it's about starting small, like not trying to jump back into your work with both feet immediately. Like I think it's okay to ease into things gradually and increase your workload, and it makes it more manageable. For people that are freedom oriented like myself, I always find that having the choice to start, it makes all the difference. So currently I'm technically on holiday. I've booked holiday, and there's work to be done. So I can choose to start at 11 a.m. and I'll work like a trooper. But as long as I've chosen to do it, that's great.
Just
So
realized
I'm
that
just hoping that'll take hold.
yeah, I just realized I didn't really introduce you. I just started chatting. So,
Just
well,
random bloke.
yeah, well, T Form has joined us. We usually stream together. Today he was a bit busy, but he's joining in now. So, well, people are asking.
Some people say better late than never.
Yeah,
Eh?
yeah, he's another maths YouTuber. You can check his channel out if you want to know more about him. But yeah, well, so we have an algebra question here. Algebraic proof. How would you represent three consecutive whole numbers algebraically? That's the
Right
first
in the order.
thing we need to think about here. Any thoughts? How would you approach this one, sir?
I can't see it because we usually share a board.
Yeah,
Um,
yeah, I didn't have that set up today.
we'll see if I can get it on. But if I go to your live stream, yeah, I'll turn the sound off. All right, using algebra proof that any given three consecutive whole number. Okay, you got to think really about what the word consecutive means, I think.
Yeah, consecutive, one after the other. Uh,
Yeah, 2, 3, 4. That's one example.
2, 3,
So
4.
when you don't know something, it's really good to write the real life, isn't it? 2, 3, 4. And now we want to turn it into any numbers that are like 2, 3, 4. Could be 40, 41, 42. So like no matter where you start, and when there is this unknown element, you can give it a letter.
Ooh, that's a big step. So, so because we're talking about algebraic proof, we want to introduce algebra. So let's say one of these numbers is x. Let's say x. What comes after x? Let's see if chat can give us the answer to this. What comes after x? What's the number after x? I want to see if someone can get this one. 5, 6, 7, 2, 3, 4, 5, 6, 7, x, y. Could be y. What's another way of writing it?
Why was 6 afraid of 7?
Because 7, 8, 9, and 10.
Yeah, had to. So if
Have
x
you
was
ever eaten a
2,
clock?
huh?
Have you ever eaten a watch?
I don't.
It's
This is
time
probably a
consuming.
joke, but I haven't know.
It's
Go on.
time consuming. I'm telling you. 2x, not 2x.
2x would be 4.
So what are we? So if you're thinking of 3, what are we adding on to 3 to get to 4? What are we adding on? 3 plus what is 4? 5 plus what is 6? X plus something. X plus something. 1. Yeah, we're adding on 1. So the number after x, how can we represent that? If we're adding on 1 to x, how can we represent the number after x?
It's actually not adding on. You've got or x there, but it's because if you say add on any number, we're not. We're actually, because it's consecutive, we're always adding 1. When something is always that, it's constant, and therefore it's a number. When it can change, it's a letter.
Well, yeah. Well, the number after x, if you're talking about consecutive numbers, it couldn't be x, then x.
No.
I'm loving, by the way, people are giving this a go. I really think that's awesome. So x plus the full expression would be x plus 1. Okay, so let's give this one. So if we give a number, if we call a number x, the number after that must be x plus 1, if we're talking about consecutive numbers. What about what comes after x plus 1? The number after x plus 1. I'll pause for a moment, see if someone jumps in. Alright, it's looking like I'm going to beat the buzzer here. Okay, so
Beep.
yeah, so when we're talking about algebraic proof, we're representing numbers with letters. We're talking about algebra, and consecutive numbers we want to represent usually as x, x plus 1, x plus 2. You can also do x plus 1, x minus 1.
I was going to say that because that's my thing.
Yeah.
Sometimes
X
sometimes
plus
you
1.
can do this and it gives you
X plus
an
2, there we go.
advantage because it cancels out the plus 1 and minus 1.
Yep. So that's what I'm going to go with. So we're representing consecutive numbers as x take 1, x plus 1. So, for example, you could say x is 3, then we'd have 2, 3, 4. Or whichever number you want to use for x there, that will give you 3 consecutive whole numbers. Okay, now we want to prove the sum of the square of the smallest number and the square of the larger number is always 2 more than twice the square of the middle number. This kind of sums up the whole point of algebra. All of these words translated into like very neat compressed mathematics. This is what algebra was discovered for or developed for.
Like a language.
Yeah, to convert lots and lots of words into short problems and solve them quickly. It's actually a useful skill. So the sum of the square of the smallest number. So if we look at this as the smallest number and we square it, we can write this as x take 1 squared. And we're adding...
Yeah.
Sorry?
Pro tip.
Yeah. And then we're adding the square of the larger number. So this is the larger number, x plus 1. Square that. And so if we add these, this will give us an expression that is hopefully 2 more than twice the square of the middle number. Okay, so now we need to expand these brackets. X take 1 all squared is x squared take 2x plus 1 plus this second set of brackets expanded is x squared plus 2x plus 1. And then we simplify. Notice we have a negative 2x and a positive 2x. They're going to cancel out. Negative something plus the same thing is 0. Then we're left with 2x squared plus 2. What is this? It's 2 times the square of the middle term plus 2. In other words, 2 more than twice the square of the middle number. So here we could write as required, or we could explain that in words. We can say this is 2 more than twice the middle number. I'm not sure that's required because basically we're just repeating what the question says, but you could, maybe there's a case to like explain what that answer means. Actually, let's have a quick look, see what they want in the mark scheme. Question 20. Okay, so you don't need actually any explanation there, you just need the working out. So just, yeah, you don't need any written explanation for that one. Okie doke. Alright. Now it's a pity you can't join in T-formula. But it's nice that you joined in anyway.
No, it's good to say hello. There's a delay because I can only look at it through YouTube, so sometimes it's a bit off.
Right. Okay, the next question is says part of the curve with equation y equals f of x is shown on the grid. Find an estimate for the gradient of the curve at the point x equals 2. Show you're working clearly. So if you ask for the estimate of a gradient at a point, you need to draw in a tangent line. A tangent line is a line that just touches the curve at the point x equals 2. So we're going to draw a tangent to the curve at that point, which just touches the curve and doesn't touch it anywhere else. So that looks good enough to me.
That's not bad. I was going to say it's much easier with a ruler in real life because you can fiddle it around a bit.
Yeah. Yeah, so with the ruler, just line it up next to the graph and make sure it looks like a tangent. Yeah.
There are tolerances, right? So you don't need to be 100% accurate.
Yes, I'll give the range of this also. They're asking your name. What is your name, sir?
I don't know. I saw this question earlier, sort of copy pasted. Well, it'd be strange, wouldn't it? My name's Joe. No, it's not. It's Joel.
Well, that's almost, yeah, that is still quite strange. Yeah, it's so similar.
All the names in the world, my friend. All the names in the world.
I'm Joe, he's Joel. Funny. Okay.
There is no better at maths, really. We know different things. When you get to a high level, there's so much mathematics, you can't know everything. We know different things. We've had different experiences.
Yeah, that's why it's good to work together and you can share different perspectives. Okay, so how do we find the gradient of a line? If I ask you, sir, how to find the gradient of a line in 2 words, what would you say? 3 words, what would you say?
3 words?
Yeah, in 3 words. How do you find the gradient of a line in 3 words? Hot seat. I put you on the spot.
Use 2 coordinates.
Oh, okay, yeah, that's good. I would have said rise over run, but yeah, use 2 coordinates is also good.
There's so many things to it,
Yeah,
I
I know.
suppose. But if you pick an exact coordinate, it's very useful. But yeah, in the second stage, rise over run's a good one.
Are logarithms only in A-level maths? Yes, there's no logarithms in GCSE mathematics. So this point here, so as you said, two coordinates to find the gradient of a line. This point is 1.5, 0. This point up here is 3, 3. So to find that gradient,
There's a calculator paper.
non-calc.
Oh, painful.
This is going to
You want to
be,
draw that line long enough so that it coincides with some nice coordinates.
yeah, exactly, yeah. So that's a good tip. So when you're drawing these tangent lines, try to make it go through some coordinates that will have some nice whole numbers, or some like nice decimals. So now we have the rise over the run. The rise from 1.50 to 3.3 is 3. The run is 1.5. So that's going to, I should use approximation symbols here, by the way. That's going to give us an approximate gradient of 2. Okay, so there I get an estimate for the gradient of 2. Now the range for this, exactly dividing rise by run, excellent. Now the range for this question was 1.5 to 3. So if you got an answer anywhere between 1.5 and 3, you'll get the 3 marks there, as long as you draw the tangent and show you're working.
That's a pretty big range, to be honest.
Yeah, well, I think that's fair. You know, these are just like these questions can be done in, like, there's such a range of the tangent you can draw on such a graph. Okay, final question. We all love these ones. Vectors. Someone earlier was asking for more challenging questions. Hopefully this one is challenging enough.
Depends what you like in life, but this is generally considered up the top end.
Okay, question 22. OXYZ is a trapezium. OX equals A, XY equals B. These are vectors. The vector OZ equals 3B. So let me write those in. OX is A, XY is B, and OZ is 3B. If you are foundation, you don't have to worry about vectors. You won't have to do these. So don't stress. M is the midpoint of OX, so OM and MX are equal. N is the point such that MNZ and ONY are straight lines. Given that ON to OY equals lambda to 1, use a vector method to find the value of lambda. Okie doke. Where to start? Well, if we're looking for ON, we can look at this triangle here, OMZ. Okay, and note that ON splits that line MZ in some ratio. We don't know the ratio, but it will split that into some ratio. So an expression we could give to ON is it would be OM plus some fraction of MZ. Let's say K, no, not K, let's say alpha MZ. So some fraction of MZ. Okay, so let's find MZ. And what we're basically going to do here is compare this expression for ON to another expression for ON we can find. And then we're going to be able to solve for this alpha. Whatever this alpha is, this fraction of MZ. So sub in k or n as a value of u, as a value, as you know, they will all lie in one line, so you're going to be a multiple of some sort. As a value, sub in k or n as a value. You've lost me a little bit there, sorry, Sahib. So OX, Y, Z, they're not multiplying these. This is just saying a shape. OX, Y, Z is a trapezium. Okay, so MZ. Let's find an expression for MZ. If we go from M to Z, we go negative a half A plus 3B. So 3B take a half A. Okay, so then ON is going to be OM. OM is a half A plus alpha times mz, which we've just found is 3b take a half a. Okay, then we could write this. If we expand these brackets, we get a half a plus 3 alpha b take alpha on 2a. Okay, so what have I done so far? I've said on is equal to the vector OM plus MN, basically, some fraction of MZ. I've found MZ, the vector MZ, and then I've subbed that into this expression up here for ON and simplified. That's all I've done so far. Let's keep simplifying this expression. Half A take alpha on 2A, I could write as A times a half take alpha on 2. Plus 3 alpha b. Okay, so I have one expression for ON. Let's find another expression for ON. Oh, k instead of alpha, right, I understand. Okay, another expression for ON. Well, ON is some fraction of OY. What is OY? Let's say it's beta OY. What is OY? That's A plus B. So another expression for ON is beta times A plus B. Okie doke. Well, that tells us actually how to solve for alpha. These two expressions for ON allow us to solve for alpha. Why? Because ON has the same, ON is a multiple of A plus B, is a scalar multiple of A plus B, meaning the coefficients of A and B must be the same, meaning that these two expressions in terms of alpha need to be equal. So that allows us to solve for alpha. So then we can say a half take alpha on 2 equals 3 alpha, because we have this expression for ON also. Okay, so this was the process I used to solve this problem. Here we can write this as 1 take alpha on 2 equal to 3 alpha. Multiplying both sides by 2, we get 1 take alpha equal to 6 alpha. And then adding alpha to both sides, 7 alpha equals 1. So alpha equals 1 on 7. Okay. Then we need to find ON. So, well, actually, we know that 3 alpha is going to equal 3 on 7. If alpha equals 1 on 7, 3 alpha equals 3 on 7. So ON, because the coefficients of A and B need to be the same, we know ON will be 3 on 7 A plus 3 on 7 B. Okay, if it's is it good to learn something more advanced? It can, well, if it's too advanced, it can be demotivating sometimes. So basically, you can try, but just don't get discouraged if it's just way too hard, because there are some things you need a lot of practice with or a lot of extra knowledge before you can learn how to do that. Yeah, that's one disadvantage is sometimes, like I can watch, sometimes I watch lectures on YouTube from mathematics, like postgraduate mathematics, which is mathematics after you've learnt, after you've studied mathematics at university for 3 or 4 years, and that stuff's too hard for me, usually. And, well, I don't really let it get to me, but yeah, sometimes it can be like, wow, this makes me feel like I don't know anything. But yeah. Okay, so we have ON equal to 3 on 7A plus 3 on 7B, meaning that ON is 3, this is 3/7 of OY, basically. So if we call OY 1, then lambda is going to be 3/7. Okay, so here we get lambda equal to 3/7 as a final answer. Okay, link to paper. Yes. Are you in the Discord? I can just post it there. That's good that you don't really mind. Yeah, it's probably the easiest. Yeah, link to the Discord is probably the easiest way for me to share it. So, let me invite you. And then let me post a link to the paper. Actually, do you mind if I post that link after the live stream, because I need to upload it and then post the link after that? It's just a bit of a process. Or actually, maybe I could just just a sec. Okay, let me find it. Okay, this should be the right one. Yeah. I put it in the notes and resources channel. All right. Any questions? Anything else you guys want to talk about? T-formula, you still there? Hello. I think he jumped off the call. Oh, you're still there.
I
Okay.
turned it to a different mode setting because I was having a little munch of something.
Okay. Cool.
trying to type something in chat, but it's not long enough. You only get 200 characters, so I'm gonna have to split it
Oh, you only get
into.
200 characters. I never knew that.
I don't know if you'd control that, but there you go.
I
It's a
don't.
good question.
I've
What does
never.
cumulative mean? Because once you get taught how to do it in a table, you just sort of repeat it. But what it actually means uses very interesting definition.
Cumulatives. Yeah, so it's like one on top of the other, like adding on to itself kind of thing.
Yeah, builds upon previous stuff.
Yeah.
And maths is like that. So it was just to put in my 2 pence in on whether you should look at more advanced maths before your time. And it's good for context, but I just agreed with what you said, and and I guess the danger is that you're learning something without the foundation.
Yeah. Um. Yeah. I'm not sure. I'm
Like
just.
you could build 2 bricks as a foundation, like you know a little bit, and so then you look ahead at the next layer and you think, okay, well that kind of fits, but it's a bit wobbly. And as long as you appreciate that you're just trying it out for a fit, then it's okay. But if you haven't got enough of a brick foundation, totally lost, and there's no building taking place.
Yeah. There's not much learning happening. So it. But the other thing is, it's not. It's not necessarily a bad thing.
No.
Like, but it's just not. You might not learn that much. That's all.
You know what they
Someone asked
say
where
about
those.
mathematics? You don't really need to be taught it if you're actually naturally gifted with it. Like these geniuses, it's kind of self-evident stuff. Kind of scary idea.
Hang on, just a sec. Someone asked where did those papers come from? They from a portal online
A
for
secret portal.
teachers. Well, that's where I get some of them. Um, but there are other places you can find them. Um, but what were you saying about maths geniuses? They don't need to learn anything.
Oh, they don't get taught. It's a lot of it is rather self-evident. So if you have this enormous potential for maths, typically you don't really need to get taught. A lot of it is self-derived, and a lot of people go into exams not being taught something, just figure it. This is not a lot of people, actually. I should reiterate. We have a few people that are like this. Most of us have to work hard for maths.
Mm.
You know, I have experienced it slightly in university. And a little story about me is that my laptop melted in my final year, and you have to do this project which lasts a whole year. So around Christmas time, when I was playing Command and Conquer Generals, um, my laptop melted, and along with my project, so I had to start again. This was like devastating to me because I love the project, and it meant I have to miss some of the lectures for a particular exam. And I went into the exam thinking, right, well, I know 60% of the content, so I should be okay. But the questions didn't come up for me that I wanted. They were only questions I'd never really studied before. I'd never been told how to deal with it. And in the exam, I went from first principles and figured out questions. So I ended up with a distinction in that exam. But if I sort of gave up and thought, well, I need to get taught this first, I would probably have ended up with maybe 30% in that exam. So, a testimony to the fact that if you've got that logical mind, you could figure things out. And that's something about self-empowerment.
Mm. It shouldn't be too delayed. It just took me a while to answer the question. I think the delay should be quite small. Just sometimes we're slow to answer the questions. Is it
We should
just
have like
practicing?
roles.
Sorry?
We should have roles where one of us answers questions.
Yeah, well, it's just practicing past papers and questions are good idea. I managed to get a grade 7 in my last mock doing this. It's okay. There needs to be depth as well. So, practice doing practice papers and exam papers doesn't always give you a depth of understanding. That means sometimes they can stick in questions that you've never seen before, and you'll be stuck because you've just been doing exam questions and you haven't been building up a kind of a depth of understanding. So there needs to be a little bit of kind of going outside your comfort zone in a way, and like practicing, building up kind of understanding of topics as well.
Yeah,
But
have you seen on my community page the document that I put on progressive overload in maths?
so that the one, uh, yeah, giving like kind of revision tips, how to revise and things like that.
Yeah, it's got a lot of that stuff in, but contained in there was a little like table on progressive overload, like how to revise for the exam based on past papers. And I feel like what I want to add to what you just said there, that although using past papers is generally like well-respected method for studying in maths, it isn't everything. And one way to get a better depth is to go beyond that level. So if you have really challenging questions, that can give you the, I guess, the framework, the support to look at it more in depth. I think that's one way to make sure that doing past papers can secure the top grades and a bit better understanding.
Hmm. So yeah, check that document out. Oh, that was on your community page.
Yeah, I'm sure I put it there. I'm just going down here.
Nescafe.
So
Have you got a
yeah,
topic?
so you'll see this big picture on our live streams that we do. I remember coming up with this phrase that I heard when I was young, which is aim for the moon, and if you miss, you will be amongst the stars. So I turned that into a little picture, and it's in that post.
Cool. Aim for the
Fairly far
moon,
back.
and if you miss, you'll be among the stars. Lovely. Nescafe, do you have a topic? Any kind of topic?
Yeah, I mean, if it's year nine, we can pull any out the bag, surely.
So what should we do next week? What topic should we cover?
For me, it's the season of exams. If it's going to be GCSE, it's going to be towards the end of the course. Most people will have finished most of the content, so they want challenging questions. If A level, they about do their mocks, they want to do walkthrough of exam, I assume.
So more exam walkthroughs. You want to go through another paper?
Yeah, I mean, I would love to have some sort of poll that was fully answered, and then we address exactly what everyone wants. But you can't please all the people all the time, unfortunately.
We Yusuf says he has graphs, function graphs left. Do you mean trigonometric functions or just in general?
And we're talking A level, right?
Oh, was he?
I don't know if you have studying. So doing grade nine specific questions would help, for example. Oh no, he's in year 11. Yeah, so I think doing the top end, really challenging yourself. You can obviously ask your teacher or us. We know how to extend any particular topic, um, and keeping it within the bounds. But there are some books you can purchase out there which are just, grade nine top end study practice questions. GCSE transforming graphs. There's not much to it, is there really, compared to A level?
Yeah, I mean, it's just, you can kind of rote learn it if you want. Just the three types of transformations: the shift, the stretch, and that's it, isn't it? You're just
There's not
shifting
much, yeah.
horizontally or vertically, or stretching horizontally and vertically. So, Nescafe, have you learned your trig ratios? Have you learnt your trig ratios? Yet.
We could talk about what different things do. Let me show you. For the transformations, here are 8 examples I've put in our chat. We could ask the audience what they think happens to the graph in these situations.
Okay. Let's have a look. Oh, cool. Alright. How do I...
You could I could send you, in fact, I could just send you that. You could write it. Wouldn't be too hard to copy it. I'll give you the answers as well. Not that it's too hard, but...
Alright. Here we go.
Pick any.
Okay, so here we have some graph transformations. What's happening to these graphs? Alright, I think we'll finish on this. Okie doke. Last topic, graph transformations. What's going on? Chat, it's all up to you.
I think we'll start at question 1, though.
Move forward to the right. No.
Good try, though.
Good try, yeah, almost. So, when it's outside the brackets... Oh, now we've got a mix. I started talking about trig, and then we moved on to graph transformations. Okay.
I think graph trans came first.
Okay. Well, we'll jump back to trig in a minute. So when the number is outside of the brackets, so f of x, think of those brackets around the x. Anything inside that relates to x. Anything outside of those brackets relates to y. Or in other words,
When
the
you say
vertical.
x and y, you mean the x and y coordinate.
Yeah, yes.
So we could talk about this in general, but we could also talk about what happens to the coordinate, let's say, I don't know, 1, 1, 2.
Yeah. So we're thinking of these, I think you're thinking of the coordinates, I'm thinking of the graph in general.
Yeah, no, I would do
fine.
both because
Yeah.
the way I learned myself, it helped to do the coordinates and then you just join up the new coordinates.
Yes. So, well, let's just draw a general quadratic. Let's draw x squared. Oh,
Yes, Yusuf. Move 4 for the y.
nice.
But we want to be more specific about the language, right? So when you say move, what do you mean move?
So, yeah, so if, like, let's say we had this point 0, 0 on x squared. If we have let's say f of x is x squared. If we have f of x plus 4, that means this whole graph shifts up 4 units, or in other words, we add 4 to the y-coordinate of any point on that graph. So the new point of f of x plus 4 will be 0, 4. So this is vertical shift up 4 units. Okie doke. What about the next one? F of x plus 4.
Tell him about the rule, Joe.
The rule?
He said 2. Question number 2 would be 4, 0. He's got it wrong, so tell him about the rule.
I don't know about a rule, but...
What happens when it's inside the bracket?
Oh, it's related to x. Well, he's transformed the x coordinate, but he's just gone the wrong way.
That's exactly it, because it's opposite in the brackets.
Oh, right. Okay. So when it's when it's inside the brackets, the sign does the opposite thing, weirdly.
Very weirdly, but also that happens consistently in math quite a lot. You think about completing the square as well that you did earlier. If you think about the coordinate of the turning point inside the bracket, you negate it.
Yeah. Yes, so this would be, so if you're looking at 0, 0, it would be at negative 4, 0. Okay, so when it's outside the brackets, when you think of the y-coordinate, the operation is as you would expect. Plus 4 shifts up 4 units. When it's inside the brackets, plus 4 does the opposite. It's negative to the left 4 units. Okay, next one. We've just done the previous two. We just need to combine them now. So what about f of x take 4 plus 2? What would happen to 0, 0? 4, 2. Nice. Nice, nice. So 0, 0 would shift to 4, 2. Very cool. What about negative f of x? Oh, reflections was the other thing I said. So there's shifts, there's stretches, and there's reflections.
I find they're the hardest. But if you, as you said, learn them like straight up, there's only 2 places that negative is going to be.
Yeah. Well, yeah, actually, I don't mind reflections because if you think, all this is saying is that for every y-coordinate, it's now the negative of that. So if we had a point at 0, what would it be? 1, 1. If we had a point at 1, 1, now the y-coordinate is just the negative of what it was before. So this is a reflection in the x-axis. So for example, 1, 1 would be now 1, negative 1.
You're negating the y-coordinate, right?
Yeah, oh yeah, also it's outside the bracket, so it's affecting the y-coordinate. It's now becoming a negative. Okay, what
that's
about...
That's a literal step because it's outside.
Yeah, yeah. What about negative f of x plus 3? Yusuf is getting his own private tutoring session here.
No,
cool.
we've got a couple of people interested. Nescafe S asked about this at first.
Okay, so if it was negative f of x plus 3, what would happen to 1, 1, for example? It wouldn't be 1, 2. Or would it?
Happens to x first.
Well, does the order matter here? The order doesn't really matter here.
The order doesn't always matter, but
No,
it can.
It does sometimes matter. Yeah, that's where I get confused when the order messes things up. So here we want to shift vertically up 3. So for example, 1, 1 would go to 1, 4, and then reflect vertically.
Yeah, I think though, just to be consistent, we should probably do it in the order of what happens to x. So the reflection first.
Sure. So 1, negative 1, then... Oh, it would be 1, 2.
It'll be the
Right?
same answer, but it's to be consistent.
Yeah. Oh, I was just too slow. Yeah, it is 1, 2, right? So this is reflection, then
Because we think it's going to go negative, but the add
vertical
3 brings it back up again.
shift. Sorry, Yusuf. So 1, 1 would go to 1, 2.
How is
Alright.
question 3 4 2? They're asking.
How is question 3 4 2? So remember that when it's inside the brackets, it's a shift to the right, so it's a positive shift. When it's outside the brackets, it's a literal. So we read it. If it's a +2, then it's a positive shift as well. So don't get confused by the negative and the positive signs. Okay, question 6. F of x plus 5. So, yeah, I said f of x plus 5, but it's written as 5 plus f of x, same thing.
But that's the weird thing, right?
Yeah.
This next few questions are when it's the wrong way round, and it's very strange.
Yeah, so this is still a vertical shift. Vertical shift up 5. Awesome. So 0 to 0, 5. What about take f of x? Yeah, it catches you up.
Well, it makes you feel like there's something wrong. It makes you doubt yourself.
So this is a reflection. Then shift up 5. So for example, 0, 0 would be again at 0, 5. Or maybe we should look at a point like 1, 1.
1 1 is way more awkward.
Okay, yeah, so 1, 1 goes to 1, negative 1, then shifts up 5. So
You could do it in 2 stages, like goes to 1, negative 1, then arrow again.
yeah. Yeah, I'm a bit scared to start drawing more on this graph because I'll make such a mess.
Oh yeah, no, you could do it with coordinates, I think.
So, yeah, negative 1, then up 5. So 1, 4. Yep. And then the last one. So there's 3 transformations here. This is where I think order still doesn't really matter here. It's only when the stretches are involved or the compressions that order matters, I think, right?
Yeah, because you're looking here at moving it to the left too. Like the effect of the x has not really much to do with the effect on the y.
Yep.
They're separate. So.
Okay, so let's say we took the point 1, 1. Where would that end up? Oh, this is a reflection in the x-axis, then a horizontal shift.
Awesome, we've got an answer. Let's see if it's right.
Horizontal shift left.
Left 2 would be minus 1, 1.
And a vertical shift.
I think Yusuf is right.
Up 5. 1, 1 to negative 1, 4. Okay, so to negative 1, 4. Yeah, negative 1, 4. Cool. Alrighty, so that's kind of basic graph transformations. That gives you, well, that was just reflections and translations. We didn't do any stretches.
You always do stretches before sport, okay? But not here.
Alright, well, maybe that's next time. Next week, we can talk about graph transformations in more detail. What do you think?
Yeah, I mean, this is a good topic. It's quite abstract. Works well for GCSE. They don't need to do too much of it at GCSE, but it's
No.
if you do it properly, make sure that if it comes up, you're feeling good.
Alright, apologies to Nescafe. We didn't really get into any trig or anything. Maybe next time. I'm been going for how long now?
Nearly, well, quite a bit. 2.5 hours,
Two and a
didn't
half hours. Yeah, that's enough for me. It's getting late. I need to get to bed. So, well, we can get stuck into other topics next week. Alrighty, thanks guys for joining in. It's always fun. And see you next week in the next live stream and any other videos in between. Alrighty, bye for now.